So today our goal is to do the taxonomy, and I'm going to run through all these setup lines here, reading in the metadata, setting that up, the taxonomy. This tax, so I've skipped over this line before. Taxonomy.tsv. There's a way to export in QIIME itself. There's a QIIME command to export the taxonomy as a TSV, as a tab separated value file, instead of as a QZA file. That's what this line here is meant to do, is to read in the exported format. The exported file has a slightly different formatting that I'm used to. But I was also, I think, before I was using an older version of QIIME. So today we're going to see if the taxonomy.qza is sufficient for our needs, or if we need to go back and export the taxonomy. So I still don't have, I ran this line and I don't have it. So we're going to try to keep going with the taxonomy.qza. So these are the beta diversity. I'm going to skip. Okay, so this line here, so I skipped down to the taxobar plot. This is line 159. This is to create a phyloseq object. So this is a QIIME to R function, which is going to convert the QIIME QZA files to a phyloseq object, which we're going to call physeq. And it's going to use the rarefied table.qza that Natalie just sent me. Rarefied table.qza, I have it now in my directory. The rooted tree.qza, which is here. Taxonomy.qza, which is here, and the sample metadata. Where's the sample bit? I have to have sample metadata. Where is it? Did anybody see my metadata file? Okay, that's it. This is my old file name from the other project, so I use tap there to make sure that that file is in the path. So those are all good. That's good. So this one I need to get the right name for it.
Okay, so this is, so if my kids have a cold,
Beta glucan metadata.
I'm wondering for a protocol.
Okay, so that ran. So this is that physeq object, phyloseq. So it has, it's not just one table or one like that we're used to, like that meta object, which just has some columns. The physeq object is multiple stuff. There's an OTU object in it. There's a taxonomy table. And these are all integrated into like one variable, which is called physeq in this case. It's got the tree. All these things that we loaded into it are now different parts of this object. And it's convenient because they're all integrated, and you can cross-reference something from the feature table, the rarefied table, to the taxonomy table to get the taxonomy of the different ASVs. So it's nice. physeq OTU table. So So that's physeq. Anybody have any question about what physeq is? Getting some head shaking. Okay. So I've done something kind of like backwards, and I could probably do something more efficient, but this is what I've done. So now I'm actually getting the OTU table back out from the physeq object. I think it's to make sure that all the names and everything match. Tax clean. So physeq OTU table. So here are our ASV IDs and our samples. That looks good. Our tax clean. Let's have a look at this. Tax clean. Tax.clean. 0 observations. Yeah, I probably have a text clean that I was working on earlier. So let's see if where's the chime to R function for reading in the taxonomy? Do you want to share your screen, Junior? Uh-oh, we lost Junior. He'll be back. He'll be back in 15 seconds. maybe. Oh, you're the host. You have to let him in. Hey, Junior. Yeah. Okay. All right. In your directory. Super fast. Is it gonna keep up? Yeah, you don't have that text thing. Alright. Yeah, it's file name. Has to be right. Okay, so we're now the moment of truth. We're gonna load in. So instead of using the exported taxonomy.tsv, we're gonna read in the taxonomy.qza. Now this is totally unscripted, and I have no idea what's gonna happen. It's just like playing a video game. We're gonna find out. Okay. So, I pulled down these 4 commands from the Chime to R tutorial. So we're going to read a QZA, which is taxonomy.qza. You can look at the first few lines of it. And it's kind of messy format. So if we look at the taxonomy object, it's actually a list and not a data frame. It's not nicely formatted. So then if we use this parse taxonomy command, this is supposed to make it into something nicely formatted. That's done. Okay, that looks good. Now let's look at this in more detail. So this is called taxonomy. So something that can be problematic is if it's unclassified. Like this NA here. So if some of these have NA for the genus. This one even has NA for the family. So this is the kingdom, phylum, class, order, family, genus, species. And if there's an NA, it cannot classify it at the family level. It knows that it's this order, Gastraneurosphiales, but it doesn't know what it doesn't have a good match to a family. So it puts NA. It doesn't know, and it doesn't know the genus. Yeah. Yeah. The databases are getting bigger and more complete and better. So there's fewer of this than like there was 10 years ago. But yeah, it's still pretty common to have some things be unclassified. And there's really not too many. There's some. How big it? There's 1,900. Let's try to get an idea of how many NAs there are. Sixteen, 62, 1932. So there's about 300 rows that have an unassigned genus. Okay, let's see. So back at the top of this, I tried to fix this. Tax 2. Let's do something here. Tax 2. Okay, yeah, that actually worked. So yeah, this line, it did. This thing here, I did not write this, and I had to Google to find out. So I don't expect you to understand it because I don't really understand it. But what this does is it looks for an NA. Here's looks for an NA, and it's going to take the value in the column to the left of it and just put that into where the NA was. So if we look for something here, Anaerovibria, let's go toward the top. Let's look at taxonomy. Or at the top of taxonomy. So the very first one, the species is NA, but it's a Streptococcus genus. So here it's a Streptococcus genus. So it's the same file, but here Streptococcus is listed as the species. Now this is a little bit tricky because now it just looks like Streptococcus is a species, but a species should actually be 2 words. So you have to take some care about if what is listed is what it actually is. So even though Streptococcus is listed as a species, it should be, really it's like an unclassified Streptococcus. I don't know if there's a way to change that. Let me just try something here. I'm probably going to get an error. Yeah. T? It didn't get transposed, right? Okay, well, I can't do this on the fly, so we're gonna go back. Now these other lines, this text 2 actually looks alright. It has row names. So we don't need this line, and we don't need this line. And then we call it tax clean. Okay. So now we actually have tax clean. Did I change this? Was this taxonomy dot, did I change that, guys? Okay. I'm gonna move these lines up to the top before the tax. Okay. Sorry, lots of skipping around. So now we have this thing called tax clean. And this one is just checking the row names and reordering so that the tax clean is in the same order as the OTU table. And metadata filtered. This is also changing the order of metadata and the OTU table so that they're the same order. And now FiSeq OTU table. Now we're actually going to make a new FiSeq object, phyloseq object, which is going to be called, so again, here's a phyloseq command. We took this reordered OTU table and a reordered metadata table. I don't know if I really have to do all this stuff. It seems like, but anyway. This worked in the past, so we're just going to use it again. So that all works. So this line is just setting some colors that I think are nice. And then I create some variables here, my level and my column. So these are going to help us make different graphs at the phylum, family, and genus levels. And then this my column, this is a column from the metadata, which have I read in the metadata? Metadata, is this our metadata? Yeah. Okay, so our diet column is called diet. So I'm going to change this to diet. This is an abundance filter, so if you remember like the Chime taxa bar plots, they list like all 2000 taxa. This filter is setting that how abundant they're going to have to be to actually make it into the graph. And so this is setting at 2%. If that taxa is at least 2%, it's going to be included in the graph. And you can play around with that. And then I ran this loop on accident. I didn't realize it was already going to run, but it's running. I get an error, course. So there's a loop here, and it's going to go through the different levels. ML and my level. So again, my level are these three things: phylum, family, and genus. So it's going to assign, first it's going to use phylum for ML. The first thing it does is print the ML, and that's why here it printed phylum, but then it ran into an error later. So we got to get rid of this litter treatment. That's from my previous example. We don't need anything with litter treatment. Group by litter treatment policy taxa. Group by phylum. I think I can just delete these. No, it's not used. This is after the loop. This code was used to make a different taxa bar plot with the litter treatment, so I think I'm going to delete all this. Alright, so there was 2 instances of litter treatment in the loop, and I deleted them. So now the loop is running again, first for the phylum, and it saved a picture. Family is running. Output phylum. I just deleted it, and I deleted the comma. So like here, litter treatment used to be here. It used to be get ML comma litter treatment, and I just deleted litter treatment and the comma. So we can go through these steps in a little bit more detail in a second. Right now I was just kind of testing to make sure it's working. So what it's going to make is a nicer graph than Chime gives us. I think you'd all agree that this looks nicer than what Chime gives us. So this is the phylum graph. And there's a family graph. So to make it into the graph, the family has to be at least like at least more than 2% in at least one sample. So this Enterobacteriaceae, dark blue, it's not really present in all these other samples, but in this sample it's greater than 2%, so it makes it in. And this purple one, Succinna vibrioaceae, it's pretty little, but I guess this is more than 2%. We're getting that because where is my filter? Abund filter. overall max filter. So here that abundance filter is being used to remove any that have low abundance. Okay, so I think things seem like they're working all right here. So genus is always a problem because now we have only about 65% of the community is shown, but we already have this many genres shown. So I mean, it gets really hard to see anything beyond that. So that's what we've got. So we've got the phylum. Not much is going on. For some reason, D has a lot of proteobacteria. And then family. D has a lot of Enterobacteriaceae. That's proteobacteria. Everything else is pretty even. And genus. So D has a lot of, what did I click on? D has a lot of E. coli. While everything else is pretty much the same. So that's kind of interesting, actually. Okay, so that was pretty successful. Let's see, did any of the unclassified things make it into our graph? Prevotella, Vibrio, Blaudia, E. coli, Faecalibacterium, Lactobacillus, Megasphaera. These are all genre names. Streptococcus, Succinivibrio, Treponema, Prevotella, 9, 7, and 1. So I guess a little bit about what's going on here. So it's grouping, it's taking our OTU table and okay, so first of all, it seems like none of the unclassified genre made it here. So that's convenient. But what's going on in a little bit more detail is if we look at that tax clean, I think. So if you remember, QIIME classifies everything as ASVs. So individual sequence types. So if one amplicon is only one base pair different from another one, they're going to get put into two different ASV categories. But some of these ASVs are classified as the same thing. They're just slightly different. So for example, these two are both Prevotella 9, and this one. So there's multiple ASVs they're all Prevotella 9. Also, there's many ASVs that are like firmicutes. Firmicutes. So what our loop is doing, what this function is doing, is it's adding up everything. It's grouping by the phylum, and then getting the total or the average. Then it's calculating the average for a certain group, which is the diet. It's also grouping by the my column, which is diet. The diet A, B, C, D, E. And then it's calculating this taxa summary, which is taxa summary right here. And so what that grouping means is we have diet A, and then all the genre listed, and the average abundance across all the animals for that genus. So we have all the genre listed that are in A, and then below that are going to be all those in B and their abundance, and so on and so forth. So we'll have all the genre for diet A, B, C, D, and E, and the average abundance for all of the animals in that group. So we're doing a lot of calculations right there. So we're and that's how we can calculate this graph for where is it? So instead of having an individual bar for every individual animal, we have a group, a bar for each diet group, A, B, C, D, and E, and we have what's listed as the average abundance across all the animals in that group. So what we're missing here is the variability. There's probably a lot of variability between animals, and that's not shown. There's like no error bars, right? But at least it provides a pretty clear picture of what's going on a group average. Okay. Any questions on that? Yeah. Okay. See ya, Junior. Yeah. Yep. We could change the code to get a graph for each individual. Like we would remove group by this. This is group by diet. So we could delete that, and then we would get the average just for each genre, for each individual. So well, there's only one for each sample ID. So that there's nothing to group because there's only one instance of each sample ID. So you could do that, but I don't think it would change anything. Now I make some other stuff here. I use taxa summary to get this summarize overall phi-seq taxa average. I think I'm getting the overall experiment wide average. So you can see here there's no diet column. This is just the average abundance of each genre across the entire experiment. I don't think I use this anymore. I think we create it, but we don't use it. I used to, that abundance filter, I used to base on the overall average, but I don't do that anymore. Let's see, what's this thing? It's just changing the column names. And then merge taxa summary with the phi-seq taxa average. Phi-seq meta filtered. Phi-seq meta overall. Oh, sorry, this phi-seq taxa average. The name is deceiving. It's not. This is what I changed. I changed, instead of doing the average, I got the maximum. Okay, so you don't have to know all the nitty-gritty details. But it is from this. So actually, this was not exactly the abundance in one sample, but the abundance in a group. So that is important to know what you're looking at. So the label on the graph is actually a little bit wrong. I say that the genus must be greater than 2% in at least one sample, and it's actually the genus must be greater than 2% in at least one treatment group and one diet group. Because it's looking at the values listed, and they're listed as diet groups, not individual samples. So that's important to know. So we could change that in our, where's our, so here's that label, the title of the graph. It's greater than 2% in at least one treatment group.